Rahim. This June 16, 42 variant and question number 4. And this is a basic criteria, velocity time graph when we have, and the gradient of any line is called acceleration or deceleration. Positive gradient acceleration, negative, this is called acceleration, and this is called deceleration. When person speeding up, acceleration, slowing down is called deceleration. And area under graph is called distance traveled. So this is called distance traveled, area under lines. Okay, so first part he's asking, sprinter runs a race of 400 meter. Okay, it means the area of the whole shape area under this all these lines is equal to 400, clearly mentioned. His total time to running the race 52 seconds. You can see here mentioned clearly. Diagram shows a velocity time graph for motion sprinter. He start from rest. This is rest. Okay, then this is starting from rest. We know clearly. Accelerate uniformly for speed is 8.2 in 6 seconds. Like he speed up, and he gets speed of 8.2 in 6 seconds. Okay, then what? After that, sprinter maintains speed of 8.2. After that, when any person gets any high speed and he maintains that speed for some time. All right, and for 36 seconds. So it means this gap is very clear. 42 minus 6 is 32. So this is the 36 gap clearly mentioned here. All right. After that, then he decelerates uniformly the speed of feed, end of race. Okay, just close. We're going to finish. He decelerates for a short interval and then he finished the race. Anyway, calculate the distance covered by the sprinter in first 42 seconds. 42 is here clearly mentioned. So I'm looking for this area of this shape, and this shape we can divide in two categories: area of the triangle separate and area of the rectangle separate, or I can go together. Even this is a trapezium shape and this is a parallel to this shape, so I can say that this is parallel like this. So this is called A and this is called B, and the gap between them is called as a H. I hope so got a point. And let's try to solve this now. So first part I'm going to solve is distance traveled. So so I have this shape. Okay, this kind of diagram I have. So this is parallel to it. One is called A and one is called B, and this is called height. And actually I made a little more slant. Anyway, no problem. A is 42 minus 6, 36. So this gap is 36. So I take is 36. And this gap from here to here, 42. So A is 42. And the gap between them, this height is actually 8.2. So I believe this idea is nothing hard. Now, part 1. So area of trapezium shape half into H times to A plus B. So H is a gap between parallel side is 8.2 and A is 36 and B is 42. Okay, and now I'm just typing in a calculator. That's it. So half into 8.2 and times 2 in the bracket 36 plus 42, and answer is I'm getting 319.8 meters in a first 42 seconds. Okay. And then he asking next part, show that the ending velocity when he will finish the race, not stop, like when he cross like finish line, the finishing line, the speed that that sprinter has, V is a 7.84, and is only possible if I have a area of this diagram. And area of this diagram is called distance traveled after that one, and it's easy. Total distance of the whole shape is 400, and distance of the first 40 seconds is, we just got it, this much. So I can say that last trapezium shape I'm going to make it, and let's start trapezium shape. So this and this is parallel to it, so this is called A and this is called B and this is called H. And it's very clear that A this 52 minus 42, so this has become 10, so this is 10. H is 10. And now students, what is this from here to there? It is V. So I can say that this gap is V and this gap is 8.2. So V and 8.2. This is V and this is 8.2. I think idea is very clear. And distance traveled in a last stage is how much? Out of 400, subtract 319.8. And when I subtract out of 400 this answer, so I get 80.2 meters. It means that I can say that the area of the last trapezium distance travel is 80.28. And now I will apply distance of area formula of trapezium. Half into h into a plus b, and perimeter splitting, 80.2 coming in the place of area, and half, and h is 10, clearly mentioned. A is V and B is 8.2. And now we are going to solve only. This 2 1s are 2, 2 5s are 10, and this 5 will come under 80.2. So 80.2 divided by 5 equals to V plus 8.2. And now I'm just typing 80.2 divided by 5 and minus 8.2, and it gives us V equal to 7.84 meter per second. Answer is proved. So Alhamdulillah Rabbil Alameen. Now I'm going for third part. And third part, what a question he is asking. Calculate deceleration of the sprinter last 10 seconds. You know, where is deceleration, students? This line is called deceleration. Okay, I need a coordinates of both like this, and I find a gradient. That's it. So let's see now how to find the coordinates of those. So a line which is like this, and x coordinate and y coordinate for this, and x coordinate and y coordinate this. So let's first of all, you can see from diagram what is x coordinate for this point, 52, and what is y coordinate is v. So 52 and v. So 52 and v. 52 and v. V is 7.84 I get from here. And the previous value here, this is x is 42, y is 8.2. So 42 and 8.2. 42 and 8.2. Now, matter of just applying gradient formula, and formula is V2 minus V1 over T2 minus T1. Okay, is called gradient formula, and it gives us deceleration. I can start from any point, but I'm starting from here. 7.84 minus this, and divide this by this minus this. So same order, 7.84 minus 8.2 and divided by 52 minus 42. And when I subtract 7.84 and minus 8.2, it is giving negative 0.36, and divide by 10, so negative 0.036. And he said deceleration, so deceleration is leave negative sign because negative deceleration word itself saying is negative. So this one meter per second square, and I believe the point is very